Start this recording. We've got like a couple weeks before you take this test.
Yeah, I take it on the 24th or 22nd.
Okay. So we probably are going to have maybe 3 total sessions before you take it. All right, yeah. We got through number 31 last time, but just as a good review, tell me the cosine of angle A. Jared?
Yeah.
What's the cosine of angle A?
12 over 5.
Cosine is what? The very first thing that you must know about trig, if you hope to get any of them right,
Opposite over adjacent.
Is this. SOHCAHTOA. Tangent is opposite over adjacent. Cosine is what?
Adjacent over hypotenuse.
What's the hypotenuse in this triangle? Look at the answers. What do you suppose the hypotenuse is?
13.
Recognize a 5, 12, 13 triangle. That is the second smallest perfect Pythagorean triangle. You're going to see it a lot. So if you recognize it, you won't have to do the math to figure out what that hypotenuse is. Now, what is the cosine of angle A?
12 over 13.
Yeah, H. All right. Let's go to 32. We did 31. That's pretty straightforward. You do the numbers first, then you do the letter A next, and then you do the letter B, and whatever you end up with is what you got.
Yep.
Okay. Which of the following sets of numbers could be a right isosceles triangle? I mean a right isosceles triangle. Which two sides have to be the same? In that triangle that I've driven.
A, B, and D.
Okay, so that's equal to that. So which of those answers could be right? Let's start with which ones can't be right. That'll make it a whole lot easier. Can F be right?
No.
Can G?
No.
Can H?
No.
Can J?
No.
Boy, they make that one easy. We don't even have to do any math, but if you did the math, that's a 45, 45, 90 triangle. We know that it's 1, 1, square root of 2, so if it's 2, 2, it would be 2 square roots of 2. Can't imagine they're going to give you any like that, where they didn't even give us 2 possible answers. All right, let's see here. Sorry about my dog barking. Okay, this equation is the equation of a line. That is a linear equation. There's no powers of 2 or any other powers. There's only 2 variables, so that's a straight line. In other words, it lies somewhere. Who knows? I don't know. It's hard for me to graph it when it's in that format. They want the y-intercept. How do I get the y-intercept? Where is that line going to cross the y-axis? There's two ways to do this. One is easy, one is relatively hard. First of all, we can solve that to put it into y equals mx plus b format. Let's do that, just to make sure you know how to do it. And then what's going to be the y-intercept once we get it in that format? In other words, when I get this equation into that format, what's the y-intercept? What letter?
-2.
B. I don't know what the number is yet. But once I get it into y equals mx plus b format, m is the slope, b is the y-intercept. That's why it's called slope-intercept format. So let's solve this equation to get it into that format. It's the first step. I want to get it into this format. Y equals some number times x plus or minus another number. So let's start massaging this equation so that we can solve for y. How do I solve this equation for y?
Yeah, y by itself.
Okay, what's the start?
Do the other side, or add to the other side.
Okay, that gives me this. What's the next thing?
-3x.
Okay, so that gives me this. Now I'm not going to write it like this because that's not in mx plus b format. So I'm going to switch the order here. I'm going to put the minus 3x there plus 2. You see why I did that?
Yep.
Okay. Now what's the final step?
5 by 7.
What's the y-intercept?
7.
Okay. Now, there's actually a slightly easier way to do this. If I move the 2 to the other side, the y-intercept comes when? When x is what? When I have a straight line and I'm crossing the y-axis, what is the x value right there?
0.
So all we have to do is plug in 0 for x and solve for y, and we'll have our answer. Now when I plug in 0 for x, this goes away. Now I got y equals 2/7. Much faster. Okay?
That only works for 0?
No, that actually works for x and y intercepts. In other words, if I have a straight line and it goes through that intercept and that intercept, well, this intercept comes when y equals 0, right?
Yeah.
Y is 0 when it crosses the x-axis. Well, x is 0 when it crosses the y-axis. So when they ask you problems about intercepts, if the thing is in standard format, like that, is all you have to do is, for the y-intercept, substitute 0 for x. For the x-intercept, substitute 0 for y. So the x-intercept would be 2/3.
Okay.
So this point right here is 2/3, comma 0. This point up here is 0, comma 2/7. You definitely want to be good at linear equations. If there's one thing the ACT tests on, it's linear equations in the XY plane. You want to know exactly what they're talking about. You want to know that slope is involved, X and Y intercepts are involved, and various formats are involved on the equation. This is standard format. Y equals minus 3/7 X plus 2/7 is slope-intercept format. Same equation, just different format. Which of the following statements identifies that curve or that line, the graph on that line number chart? In other words, this is not in the XY plane. This is a graph, but it's on a number line. So if I said X was between there and there, which of these statements says that?
H.
Good. So you know the difference between the open circle and the closed circle. All right, good. What is the perimeter? Let me knock that down just a little bit. What is the perimeter of that figure? This is a fairly difficult problem. Not terribly difficult, but it's not obvious right off the get-go what to do. To get the perimeter, we got to figure out that side and that side, right? Okay. How are we going to do that?
I'm not sure.
Well, how about we draw a line across the bottom? What's the length of that?
6.
Okay, these are all right angles, so it's a square. Okay, now what's this angle right here?
30.
No, this angle is 30. What is this angle?
150.
A right angle means what? If you have two angles that make up a right angle, what do they have to add up to? Okay, so what's this angle?
60.
Okay, now if I drop a vertical right there, what's this angle right here? It's a right angle. The two non-right angles of a right triangle have to add to what?
That would be 30.
In other words, they're complementary. These two angles were complementary, as are the two small angles in a right triangle. What's this measurement right here?
30.
Now we got what we need. If we go to our standard 30-60 right triangle, which I've been talking to you about for ever since we've been working together, what are the unit dimensions on this? What's opposite the 30?
60.
1. That's why I call it my unit triangle. 1, square root of 3, and 2. You must memorize this, otherwise you can't use it when you need it. In other words, you don't just memorize what the unit dimensions are, because this triangle we're looking at is a similar triangle. All 30-60 right triangles are similar. So if the side opposite this 30 is 3, what is the hypotenuse of this triangle?
2.
What's the similarity ratio? The hypotenuse of this triangle was 2. But this is not the same size triangle. How much bigger is each side on this triangle relative to this triangle down here? It's okay to say I don't know, but don't just guess.
I don't know.
Okay, well what's the side opposite the 30-degree angle there?
3.
What is the side opposite the 30-degree angle in this smaller triangle?
1.
And the side opposite the 30-degree angle in the bigger triangle is 3, so what's the similarity ratio?
3.
3 to 1. Means every side of that triangle has to be 3 times bigger than that triangle. What does that make the hypotenuse?
Times.
What's the hypotenuse in this small triangle?
2.
Every side of this bigger triangle has to be 3 times bigger. What's the hypotenuse in this bigger triangle? Alright, let's start from the beginning. Because this is not, you need to know this. You absolutely have to know this. We know we have similar triangles, right?
Yep.
Because it's a 30-60 right triangle. Well, this is a 30-60 right triangle. So for me to solve for the hypotenuse of that big triangle, I need to figure out what the hypotenuse of the little triangle is. I need to figure out the similarity ratio, and then I need to multiply the hypotenuse of the little triangle by the similarity ratio. What was the similarity ratio?
3.
So what's the hypotenuse of the big triangle?
6.
Okay. What's this other side?
6.
Now what is the perimeter of the entire figure?
All
Alright. Let's look at 36, and then I think we'll probably go to the next test. Merely because you and I need to be focusing on the easy and medium problems. And usually on these practice tests, when you get to the last third of the test, it's all their high degree of difficulty problems, and we don't want to be wasting our time on those. When you take this test, if you can get all the easy ones and most of the medium ones, you'll score just fine. You don't need to worry about getting all the hard ones. There'll be at least 10 hard problems out of 60, at least. Make sure that when you take this test, you spend your effort on the easy and medium ones. It'd be silly to do 50 easy ones and 10 hard ones when you could do 40 easy ones and 10 medium ones. And then the 10 that you don't get to will hopefully be the hardest 10. Because imagine you're going to run out of time before you get a chance to do all 60 questions. So this is a pretty important step, is making sure you do the easiest questions, and making sure you're good at those. So this is one hard one, but let's talk about it. It's not really hard. What is true about the expression under the radical sign? This. What does it have to be? Look at the answers, so we know what kind of things we're looking for. Now tell me what that I have circled there has to be. Can you take the square root of a negative number?
No.
So what does it have to be?
Positive.
All right. So that has to be greater than 0. Greater than or equal to 0. All right. So that narrows the problem down. The 3 doesn't have anything to do with it. The 2 doesn't have anything to do with it. That thing is positive only when this is positive. We know it can't be 0 because they're already telling us it's equal to a plus 4. So now is all we have to find is which statement makes this true. Must they both be negative?
No.
Can they both be negative?
Yeah, because it's one negative and they become positive.
Yeah, so they can both be negative, but clearly they can both be positive also. So obviously F and G aren't going to work because we know they can both be negative or they can both be positive. Now let's go down. H. Perfect. They must both be positive or they must both be negative. All right. Let's go to test 2, starting from the beginning. Sorry about the blurriness. X plus 3 equals n. What does 2x plus 6 equal to? Look for shortcuts. In other words, not every problem needs to be solved by plowing into the algebra. In other words, the first response might be, well, let's solve that for x, and then whatever I get, I'll substitute over here, and I'll have an answer. Notice all of our answers have an n in them. In other words, we're not looking for a number, we're looking for a function of n as an answer. Well, that would be the hard way to do it. Check the two relationships they're giving you. Is there any relationship between that? Between x plus 3 and 2x plus 6?
Yeah.
What is the relationship between them?
It's going to be x plus 3.
Huh?
An x and a 3?
No, what I'm saying is, what is the relationship between that and that?
One's twice as great.
That's the answer I'm looking for. It's twice as much. So if it's twice as much, what's the answer? If this one's equal to n, and this one is twice as much, what is that one equal to?
2n plus 3.
Huh?
N plus 3.
Okay. If this is equal to n, and this is twice that, then it means that. You see why?
Yeah.
All right. Because this becomes 2x plus 6 equals 2n. In other words, if this expression is twice this expression, then it's got to equal to something that's twice this. That's the fundamental thing of algebra. If you do something to one side, you got to do it to both. Again, they're not looking for a number. They just want you to distribute this and pick from the available answers what it is. So distribute this. Distribute the A.
AB minus 2A minus A.
No.
Plus 6.
Okay, when you distribute something, you multiply it by that, and then you multiply it by that. So you get AB minus 2AC. When I multiply A times 2C, I get 2AC.
Yeah.
Okay, so that's the answer. That is G. Multiple choice didn't really help a whole lot with this question. We had to do it. There's no way to back solve it or anything. Okay. Here we have a sequence of 5 numbers. This happens to be an arithmetic series. But you don't need to know that. So all you need to know is what they tell you, which is that the difference between any 2 consecutive numbers is the same for this whole series. Excuse me, there were 6 numbers. Yeah, A is right, because only minus 4 works for that spot there, since we saw that there's a difference of 7. All right, can you read that okay? It's a little blurry.
Yeah, I can read it fine.
Okay. So this is an average problem, a mean problem. I don't mean mean as in hard, but when they ask either about average or about mean, they're talking about the same thing.
Okay.
How do you get the mean?
Add everything together and divide by that number.
Okay, so let's add everything together. What do we got? We've got $20 for the first one. What do the other 5 cost? Again, look at your answers. Don't come up with a number because they're giving you an expression as the answer. They're not giving you the answer.
849.
What's the cost of the other 5 CDs? They're each $8.49. How would we get it? If you got 5 CDs that are each $8.49, how do you get that total?
8.9 times 5.
Okay. And you said originally, what do? You divide it by how many there are. How many are there?
6.
Find that answer on there.
G.
Okay. That's correct. Notice what would have happened if you'd have come up with a number here. Let's say you come up with 46.70. In fact, let's say you go ahead and do the whole math and you come up with $11.13 for the average. Notice that does you no good at all. That's not on there. So always make sure you look at the answers because that'll tell you how far you have to take the problem. They didn't really want a number for an answer. And we wouldn't have known that unless we looked at the answers before we tried to answer it. You read that?
Yep.
Okay. Do you have a calculator in front of you?
Yep.
Do this however you can, as quickly as you can. I'm not convinced the calculator is the best way to go, but maybe if you know your calculator well, it could be. So what are you going to do, first of all? what's the first step? The only step. What are you going to do? You're going to multiply these two numbers? You're going to add them? You're going to subtract them? What are you going to do?
Subtract them.
Now, do that problem as fast as you can. Okay. How did you do it on your calculator? Did you do it using fractions or decimals?
Decimal.
So you did 18.25 minus 10.5 and you got 7.75 and you recognize that as 7 3/4?
Yep.
Alright. Does highlight one of the problems in doing these on your calculator. Your calculator incidentally has a key on it that will switch fractions to decimal and vice versa. So when you got that answer, you could have pushed that key and it would have told you 7 3/4. Not that you need that here, but it could be useful. Do you know how to do that on your calculator?
No, I didn't change it. It said my answer is 31/4. I changed it to a fraction.
Well, that's fine. 31/4 happens to be 7 3/4, so that didn't help either. So it actually worked better for you having it as a decimal. All right. As long as you can maneuver between decimals and fractions, you'll be all right using your calculator. The other way to do this would just be to manually do it. Find the common denominator of fourths and go from there. Okay, I'll write this one because it's so blurry. They're telling us that 3 to the x power is equal to 81. They don't want to know what x is. They want to know what 2 to the x times 2 is equal to. So what's the first thing we want to solve for? This is a two-step problem, as most of them on the ACT are. It's rare that you have a problem like this, where there was only one step, subtracting this number from that number. Far more likely that you get two-step problems, where you have to find something first and then use that information to find what they're asking about. So what do I have to figure out first?
What's x is?
Okay, what is x? How do you solve that? You don't really have the tools to solve that yet.
In the fourth.
Okay. What they want is for you to have this memorized. They want you to know that 3 to the 4th power is equal to 81. They really have not given you, it takes logarithms to solve this. If I made this 80, then we don't have a way to solve it for x. But as long as they're going to use perfect powers of 3, which is what they're doing here, they want you to know that x is 4. So now what is this equal to if x is 4? So I have 2 to the 4th power times 2. Now that one you can do on your calculator if you need to.
32.
All right. 7 is another one-step problem. How long is the fence that goes around that garden? There's the fence.
170.
Okay. Alright, now on these, be very careful about how you solve them. Don't take shortcuts. By that I mean plug in using parentheses and then go from there. So what's the next line I'm going to write?
Minus, parentheses, negative 6, squared, minus 2, parentheses, negative 6, plus 21.
And that's the best way to do it on every single one of these. Because what they're trying to do is to get you to screw up your internal math here, because they got so many negative signs here. So what is that equal to? Use PEMDAS.
Negative 36.
Good. What's this equal to?
12.
Plus or minus?
Plus.
Notice that you can't just write 12. The plus cannot be assumed. It's part of an expression. So unless I put a plus in front of it, I won't know whether to add it or just to look at it. Plus 21. Add those three numbers.
Negative 3.
Okay, good. See, if you can get all the problems like this correct, and you should be able to, you'll do okay on this test, even if you can't do any of the hard ones. As long as you can do the easy ones and the medium ones, you can score decently.
Okay.
So, if I have a ball that's 2 inches radius, what's the volume to the nearest cubic inch? So what's the next thing I'm going to write? Same problem as the one we just had. It's giving you a value for R, and it wants to know what it's equal to. So what's the first step?
4/3 times 5 times 2/3.
Okay. And always do that step. Don't do this in your head and then try to substitute it. Write it out and then go from there. What's the next line? That's the next line, 4.18? All right. When I say the next line here, let's take apart this piece by piece. Don't try to do it all at once. Use PEMDAS. What is 2 cubed?
8.
Okay, now use your calculator to solve that and come up with a number. 8 times pi times 4/3. And they wanted it approximately to the nearest cubic inch, so D has to be it. Even if you came up with 33, D would be it.
I got 33.5.
Right. Okay, good. Okay. Now, they're saying 4C minus 2D is the equivalent of which of those expressions? Well, so what do we have to do? notice that most every one of these answers has a parentheses with a number in front of it. So this is a back-solving problem. You can't solve this problem with just this information. The only thing we can do is check each one of these answers, distribute, and see if we got the same thing. Well, what does F give you when you distribute it?
4C minus 8D.
So that's not it. G clearly isn't it.
Okay.
All right, good. I think we got time for one more, at least, maybe more than one more. We actually started a little late. If you want to go a little over, I don't have any problem with that. I kind of screwed up and not remembering that I had to call your home phone.
Yeah, it's alright. I just tried to get my dad to give me mic, but just haven't gone to the store and got one yet.
Yeah, they're pretty cheap. You can get a real nice stand-up mic that just is a USB plug-in for like 20 bucks. So I don't know. It might be better to use one of those headsets. Those are very cheap also. I think that they probably are a little bit better. I probably should be using one myself, but I don't believe I have. Every now and then I'll have an echo problem. But as long as this works for you, this works perfect for me. I don't have any problem with it as long as I remember to do it. You're not sitting there with a phone held up to your ear, are you?
No, it's on speakerphone.
Okay, good. And as long as you can hear okay, that's all that matters. You don't really need a mic. It doesn't really add anything to the experience. So how much do you get per lawn?
$20 plus fixed amount.
This is definitely a two-step problem. Could be a three-step problem if you don't spot the shortcut, but the most efficient way to do it is a two-step problem. The first step you have to figure out is how much you make per lawn. So if you get $95 for mowing 5 lawns, but 20 of that is just for showing up, how much did you make per lawn? Subtract the part they gave you for just showing up. What do you get?
35.
And you did 5 lawns. How much did you make per lawn? How do you figure it out?
You're 15 per lawn.
All right. In other words, we divide by the number of lawns we did. So we're getting 15 per lawn, and today we're actually going to mow 7 lawns instead of 5. How much are we going to make today?
$125.
Good. Did you just add 30 to 95, or did you multiply 7 times 15 and add 20 to it?
I just added 30 to 95.
That's the best way to do it, by far. Let's at least get to another page. Oh, a page we can actually see. Must have had the sun shining when I took this one. Another pretty easy problem. This is as easy as they come. So how do we simplify that? Combine like terms. like terms are x's or y's.
5x plus y.
All right. Which of those equations is not linear? In other words, every one of these represents a straight line except one. This is something you really want to be able to recognize instantly. What makes linear equations? What makes linear equations is when you have x to the 1 power and y to the 1 power. What makes nonlinear equations is when you put exponents like that in there, or higher. In other words, to be linear, it can have at most an exponent of 1 on one of the variables, or on both the variables. That's exponent of 1, that's exponent of 1, both of those exponent of 1, both of those exponent of 1, What does this look like, that curve? It's a parabola. All quadratics are parabolas. So if I take y equal x squared plus 7, is all I'm doing is taking that parabola and moving it up 7. So that's what it looks like. But we don't need to graph it. All we need to do is recognize that when you have x squared in an equation, you're going to have a parabola. Now, not if it was this. If I gave you that, well, that's the same as y equals plus or minus x. That's two straight lines. So just finding a square doesn't make it a straight line, but finding one of the variables squared and the other variable not definitely makes it a curved line.
Okay.
All right, why don't we end it with 13, and we'll pick up with 14 next time.
Okay.
All right, Jared, have a good week.
Thanks, you too.
Bye-bye.